And take 2. Okay, so different technique for taking derivatives based on the stuff we've done with logarithms. It will allow us to take the derivative of big scary functions, and it will simplify our life in general. So it looks something like this. I want to be able to take the derivative of that big scary function. But you'll notice at this point in time you could do that, but it's a quotient rule with 2 chain rules wrapped up inside of it, whereas if we do logarithmic differentiation, it's quite a bit easier. And then at the bottom there are the 3 steps that we're going to go through in order to solve that derivative. And they'll make a little bit more sense once you see me do it. Okay. Questions so far? Beautiful. All right, here we go. First thing I'm going to do is take the natural log of both sides, which gets me to that. I'm going to forget about the left-hand side for a while. Would anybody happen to know what I should do with the right-hand side of that equation?
Apply the properties.
What's that?
Apply the properties.
Apply the properties. What property would you apply first?
You'd make it ln x minus 2 squared in parentheses minus ln square root of x squared plus 1.
Well done. Because the natural log of a quotient is the difference of the natural logs. Then?
Should I keep going?
Yeah, go ahead.
Okay, then you do make it 2 ln x minus 2.
Bring the exponents out in front.
Minus 1/2 natural log square or x squared plus 1.
And we still know that that's equal to the natural log of y. Okay. Nothing else we can do with natural log properties. You can't split up that natural log of x minus 2 or that natural log of x squared plus 1. Leave it like that. So then we go on to step 3, which is take the derivative of both sides. So, what's the derivative of the natural log of y?
0 y.
Not 1 over y.
1 over 100.
Y prime over y. Very good. If it was just x, it would be 1 over x. But since it's something other than, just for giggles, what's the derivative of the natural log of smiley face?
1 over smiley face.
Smiley face.
Good. Smiley face prime over smiley face. What's the derivative of the first term? What's the derivative of 2 times the natural log of the quantity x minus 2? I'll start you with the 2. There you go. Go. Actually, raise your hand.
No, I was not listening.
Just waving your hands in the air like you just don't care.
No,
What were you doing?
I was going to explain something, but then it just didn't work out. So.
Okay.
1 over y prime. Did we not just say that?
Yeah, that's what
I literally don't know what to say. I'll ask my question again, though. What's the derivative of the natural log of x minus 2? 1 over x minus 2. The derivative of x minus 2 is 1. There's my prime. And then the thing itself. Okay? Minus, I'll give you the 1/2. What's the derivative of the natural log of x squared plus 1? Good. Okay, that's the hard part. Now, the easy part is cleaning things up. I can cancel that 1/2 with the 2. And so I get y prime over y is equal to 2 over x minus 2 minus x over x squared plus 1. Okay, not done yet. Why am I not done yet? Solve for y prime, so I have to move y to the other side. However, what's y equal to? Oh, you guys are such a bunch of babies. All I'm going to do is write x minus 2 squared over the square root of x squared plus 1. That's all. That goes away. Why are you freaking out? Did you think I was going to make you do something like distribute and find a common denominator so that you have one fraction? Nah, that's ugly. Because I'm assuming that you could do that on your own.
Yeah.
Yeah. Okay, good. Is that a safe assumption?
Yes.
Outstanding. Now, you may be looking at this saying to yourself, that doesn't look any easier, but I guarantee that if you were to go through and do that problem with a quotient rule and chain rules, it would be uglier, or at least as ugly, if not uglier. It probably also wouldn't look the same. Your answers would be in different forms, but the values would be the same. Okay. Logarithmic differentiation. One more thing for you, and that is a cute little theorem. Let's suppose you have the natural log of the absolute value of something. It doesn't matter. Why wouldn't it matter? Remember the natural log graph? No negative values, therefore the absolute value doesn't matter. So if you did, don't touch the screens. If you have the natural log of the absolute value of something, it's just u prime over u. That's going to become relevant when we start taking the integral of some of the trig functions we haven't done yet. Okay, we'll get some funky answers there. And that's all I got for you, except this.
It's a log.
What kind of log?
Natural
It's a natural log, yeah. Shut up.